Hello everyone, I'm Young First. Welcome to my channel. This is series about self-mock technical interview. Today, we will solve the daily problem in LeetCode together. Let's start. Oh, hopes it's a hard problem, so I think we should solve it within 30 minutes. Let's start. Usually in my experience, the daily problem is are easy or medium when work days and hard in weekend. So it's more convenience and you have more time at the weekend to solve hard problems. So let's read the description together. Given a string S, consider or duplicate substrings. Continuous substrings of S occur two or more times. The occurrence may overlaps. Return any duplicated substring that has the longest possible length. If S does not have duplicated substrings, the answer is empty. So let's start. The length is 3 multiplies the power 10 of power 10 of 4. So it's quite an large length. So let's think about it. First, let's write some analysis about the brute force solution. We can iterate from our substrings, and if the substring occurs more than twice, so we return that. We can iterate from the longest substrings, that's R, and then the length subtract 1 and length subtract 2 until the end, until we enumerate all the substrings. So the time complexity is I think is we need to iterate all lengths of substring. It's 0 to the length. If the length is n, and then we need to find all substrings of this substrings. So it's n2. So the time complexity is the square of n. So we will get a TLE, aka time limited exist. So we need to try to optimize our solution. So in fact, if we read the description, there is a pattern here, have the longest possible length. we can see if the answer the longest length is x. We assume that the length is x. For any I which is less or equal to x, and from length from the 1 to x, there is a duplicate substring, because you can think that if we have a string occur twice, we can the substring of the answer, the string occurred twice too. So here is a here we can use the binary search to solve this kind of problem. You can think that for length from 1 to 3 until n, until x, we can find the substring that the length is between 1 to x. The substring occur twice, and for large length we can't find that. So it's a typical property of binary search. We need to find the partition index here. I think so. So with this binary search solution, we can have the time complexity is log n and multiply the n, because for each length we need to iterate all the substrings that the length is your test, and check our possible substrings. So here is the n. So let's start to write the code. There is a pattern to write the binary search code. So we need to have no variables, which is lower the range of lower and high. In fact, I think it's here is I read some comment here no high. In this range, we can find the we can reduce the length of the range low and low to high until it's empty. And how to reduce it? We need to binary partition the range. So yeah, the mid variable is the middle of this range. We need to use this style instead of this, because because there is a integer overflow risk, but this doesn't have the integer overflow risk. So, and we need to check the middle index. If I will write a function check the mid, check mid, which is I will write that. I will write a function to check whether there is a substring of length x, which is duplicate. Return yes if there is one. Return false if there is no one. So if there is one, we need to let the low as mid as 1 and the high mid. Okay. So at the end of search, we got the low is here, because this is the first index that the check return false. So let's return. So the answer of the longest length is no subtract 1. So here, and we need to here, let's write the check first. So here we get the answer length, and we need to find the duplicate substrings. We of course we can use the length and iterate one more time, like check to find the duplicate substrings. But also we can use a array to record the answer, and we calculate the duplicate substrings in the check and store that, so that we can return here directly. Of course, if so that the so I think duplicate 0 is empty, because the length is 0. So if x equal to 0, of course it's return true. And if it's larger than 0, we need to find all the substrings. So let's use a set to we need to set to record the substrings we have seen, and iterate our string, our substring with length x. So we need to 0 and I plus the x larger than n. Here is a in fact we have the view, I think, instead of string. But I'm not familiar with the API of string view. Let's use the string first. If we got a time TLE, we will try a string view then. So let's write string substring is equal to SDN substring, and here is the begin index. I think is x, and the length is x. So if we have seen that, we need to return true, and we need to record the answer. Else we need to return false. I think that's all. Let's run the code first. It's interesting. So let's print something. For example, see out the check answer here. Let's print the state of the binary search. And this is false. And false. Hopes, I think when x is 3, when the check should return true. Let's check the check. Okay, we need to add the string we have seen. I forget this statement, so let's run it again. Oops. Okay, I think here is something trick. If the x is 3, here is 1, 0, 1, 2, 3, 4, 5, 3. Okay, I know what is wrong. Here we need to be careful with this condition. It's less or equal to because we need to include the last one here. If it's just nice, the last substring will not be included. So let's run it again. So let's submit it. Oops. TLE. I think something is wrong here. Maybe this is because the substring here. We in because in this one we use the substring, it get the a new string every time, so it's a time waste. So we may need the string view API of C++. Let's see that. Oops. We'll see the CPP reference. It's substring, return a substring. Here, I don't use this class very much, so I need to learn something. So I need the construct, maybe. As other. Here. String. We need to construct a substring string to string view. Oops. We may need to use here. Let's use that. Auto string view. String view is constraint. View as construct the string view, and here we use our string view. String view. Let's run the code. Oops, no match. Let's see the API. I think there is a review no. Let's do that. How to do that? Review. SV. Yes. I think that's it. Be a type. Okay. So screen view. Oops, yes, we may need two screen. Yeah. We need to convert substring to string at the return statement. Here, maybe this. Oops. Let's run the exam again. And copy the this large test case too. Yes. Let's submit the code. Oops, I get the TRE again, but there is no example here. I think it's because I passed every test cases, but the total time is exceeds the LeetCode limit. So. I think this is because the check is a bad check. The time complexity of the check is not n, because there is a for loop, and when we use the hash map, we need to calculate the hash of the substring, but under the hash function, I think the time complexity is related to the length of substring, so the total time complexity is the square of n in check, so we got the log n multiply the square of n, so we need to optimize the R check function. In fact, I know optimized solution for this situation. We have a rolling hash technique to deal with this situation. We can use rolling hash to reduce the time complexity inside of the for loop to constant. Let's do that. It's very easy to implement. In fact, here I think it's int, and we have a hash now, current hash. Let's rename the current hash is 0. We need to calculate how to calculate a hash here. X. Let me calculate the first hash here. The first hash is in fact it's more like 26 based number. You can here and plus si a here. We need unsigned unit effect here. Because the rolling hash don't want the overflow of integer. With the unsigned integer, it will discard the overflow automatically. So here, and we need to push C inside. Nice. Current hash, and it's for 1, and here is a unit again. Okay. We need to the current hash is equal to current hash. We need to subtract the first digit. It's SI. We need to power here. It's the power of the power weight of the first digit, and then we need to shift it left digit, and plus the current plus the last digit. I think here is 1, and what? Here is X. Here is subtract 1, and if we find the current hash, we will we will record the begin index, and return that. So here we need to change it to int and 0, and in the here we need to get a substring. The begin index is the duplicate string answer, and the length is the answer. So I think that's it. And now we need to calculate the power. The power I think is unit. Let's get this at it's 0, it's 1, and I need to here we got the power. As the power, I think I need to how to do that? In fact, we need to multiply once less, so I do that in a separate for loop. So let's run the code. Oops, the answer. Here is something wrong inside our new check function. Let me check that. Hash. Let's do some debug here. Oops. Let's add some debug print message. When the n is okay. Banana. Sync the current hash. Return. Oops. I think there is a bug. We need to remove the remove the left digit, so it should be I subtract 1, because in here the substring is from I to I plus x, so here is the discard digit. So let's run the code again. Yes. Let's comment the print statement and run this one. Oops, and the largest one. Let's submit that. Run answer. Output. I think my algorithm is right. Because we got the expect answer for other test case. I think this test case is a hack for the overflow, because in the rolling hash we use the overflow for with the unsigned int. In fact, it's not good practice. In a good practice, we need to use a big prime. Use a big prime here. For example, I think this one is large enough. Let's use that. And we need to use that. We need to use the mode to do the overflow to the detractor. Let's run it. Oops. This mode is not big enough. I will use insert on do this. This is really big. I think it's a good practice. That's right. Too much. Present. And it's too much. Oops. Maybe this one. We need to enlarge prime, but it need to fit in our data type. So I think that this one is a good prime. Oops. Inspect. Okay. In this situation, the output is less than the expect, so it's I think this is false. This is not related to the big prime because the output is less than expect. If it's larger, we something is wrong. Let's check our code together. EL Oops. Just I think it's a corner case we need to take care of because let's run let's store it first. And write a small case. Oops. This one. But this one is maybe 0 x y z third hash. Okay, I think I may know the problem. This is a complex statement. We may need to mock it first and plus mock. Oops, this is not a function. Oh, it's a problem on set. Let's run our examples. So let's submit it again. Oops. That here is back to output. We may use this one. Yeah, let's submit it again. This is I think this is a hack test case to forbid this prime because it's a common prime. So someone would design a test case to hack this because we use the ruling hash. Risk for that is there may be a situation that two substrings have the same hash, but they are different string. If you select a prime, you can design a test case to hack this prime. So we we shouldn't use the common prime. Instead we just random search a big prime. So I think that's my today's video. It's a long video about an hour because we met some stuck here. I submit about six times and get the accept finally. And if you so I it's a good practice to use a binary search and rolling hash. If you are interested in the two tricks, you can have some practice to it, and these two solutions have some pattern. You can see that the pattern is very clearly, and here is the rolling hash pattern. I haven't implemented the rolling hash for a long while, so I get paid today to make some mistake and spend a lot of time. So thank you for watching my video till the end. I think there is not too many people still watching here for an hour. So thank you very much. See you tomorrow. Bye bye.